Everyone, am I audible?
Yes, sir.
All right. How is everyone? Gautam, all right? Okay. Abdul Arsalan, your mic is working. I guess not. Irfan, Shrapya, you are new here.
Yes, sir.
All right.
Yes, sir. I am new here.
Okay, this is your first class, right?
Yes,
We
sir.
are studying.
Yes.
Yeah, we are studying relations and functions chapter. All right. We will be finishing this chapter in the next 2 classes. After that, we are going to start term 2. All right. You can also revise in the meantime. This is what we are going to do today is very important. All right, for 12th also. So please try to focus. All right. In the last class, we studied domain, codomain, and range of a function. Irfan, do you know what a domain is of a function? What a domain is of a function? Irfan?
Sir, there is some problem. It's getting. Sir, the
I'm
sound.
sorry. The
Sir,
sound is breaking.
Yes, sir. It's breaking.
All right. Is this problem coming to everyone or just Irfan? Shravya, Gautam, can you hear me?
Yes, sir.
Sir, now okay. Now okay, sir.
All right, all right. Irfan, can you tell me what domain of a function is?
Sir, could you repeat the question?
What is the domain of a function? What do you understand by that? If I ask.
Yes, domain of a function means the x coordinates of a function.
X coordinates. All right, Shabya, what about you?
Yes, sir. According to this, set A is called as domain.
Right, absolutely right. All right. So you guys know about this. I don't have to revise, right? Okay, let's start with the question. Let A equals to -2, -1, 0, 1, and 2. And f is from A to Z, given by f of x equals to x squared. All right. Or you can A to B, make it A to B, and this is set B 0, 1, 2, 3, 4, 5, 6. You have to tell me the domain and range of this function. Make it B. All right. Gautam, Abdul Arsalan, clear the question? This is a function. You have to tell me the domain range of the function. And codomain also. Find domain, range, and codomain. All right, done, everyone. Irfan has answered. You still have to answer codomain, Irfan. Okay, Shravya, Gautam, Abdul Arsalan.
Good, sir.
All right. I'll give you 1 minute maximum. Another minute. All right, done. Gautam.
Yes, sir.
All right. Let's check. See, I told you in a function, the first set defined here is the domain, right? So domain is set A. All right. And the second set defined is codomain. A range you have to find out. All right. You have to first out f of -2. That will be -2 square. That is 4. F of -1. That is 1 -1 square is 1. F of 0 is 0. F of 1 is 1. F of 2 is 4. So we are getting only 0, 1 and 4, right? So the range is 0, 1 and 4. All right, everyone. The first set is domain, second
Yes,
set is codomain. Yeah, and the values we get is range. Clear, Gautam, Abdul, Aslan?
Yes, sir.
Yes, sir.
All right. Let's try another question. Let f be a function from n to n. Here n stands for natural numbers. And f of x equals to 2x minus 3. Then check if it is a function or not. All right, I'll give you 2 minutes for this. How to check? You have to see or give any example where the domain or range is not from natural numbers. All right, domain is all natural number, range is not from natural numbers. All right, one example is enough to prove that this is not a function. All right. Yes, not a function. Write it on. Let's give other people 1 minute. All right. All right, done. Gautam, Shabya, Abdul Arslan. All right, let's check. See, I told you in the last class that for a relation to be a function, the elements here should be related to at least one object to here, right? So here we have natural number to natural number. If I put f of 1, I'm getting 2 into 1 minus 3. That is 2 minus 3, that is minus 1. This does not belong to n, right? So 1 is not in this relation. Means 1 here is not connected to any member. So this cannot be a function. Is this clear to everyone?
Yes, sir.
All right. Gautam,
Yes, sir.
all right. Write down equal functions. Irfan, when are two functions equal?
Sir, I don't know. Sir.
I don't know. All right. Shabya,
So two functions are equal when domains are equal, as well as the codomains.
all right. Is that all? Okay, let's see. Let's write down two functions f and g will be equal when the condition is domain of f should be equals to domain of g. All right. Codomain of f equals to codomain of g. Third is, and this, don't forget this condition. This is also very important. All right, 3 should be there. F of x should be equal to g of x for all x that belongs to domain. What does this mean? That these two are not sufficient. All right, for each value of, suppose there are two functions, all right, f and g. If I find out f of 1, then this should be equals to g of 1. All right, this is also necessary. Write this down, these three conditions. If they ever ask you whether the two functions are equal or not, you have to just check these three conditions. We have to find the domain, the codomain, and see if this equals to this.
Done, sir.
All right. Let's try a question. let a equals to 1 comma 2 and p equals to 3 comma 6. Right, and f is a function from a to b given by f of x equals to x square plus 2, and g is a function from a to b given by g of x equals to 3x. Check whether f and g are equal. Right, these three conditions are there. Check, you have to check the domain, codomain, and this condition, f of x should be equals to g of x. All right, done. Gautam, Abdul, Shabya, Aslan.
Yes, sir.
All right, let's check. See, here the domain is a, here also domain is a, so domain of f is equals to domain of g, right? Codomain is also equal, b to b. Now we have to check each and every value for 1 and 2. So f of 1 is 1 square plus 2, that is 3. F of 2 is, this is 6. We have to find g of 1 also. So this is 3 into 1, 3. G of 2 is 3 into 2 is 6. So now I can say f of 1 equals to g of 1, f of 2 equals to g of 2. So all the three conditions are fulfilled, so they are equal. All right, Gautam, clear?
Yes, sir.
All right, note it down. Shall we move on?
Yes, sir.
All right. Another question. Find the domain for which the given functions are equal. All right. F of x equals to 2x square minus 1 and g of x equals to 1 minus 3x. You have to find the domain for which these functions are equal. I'll give you 2 minutes for this. All right, done. Yes, Irfan, you have answered this. See, when they ask you what is the domain or anything like that, so that the function are equal, put them equal. All right, write it like this. This is equals to this. Then find the value of x. 2x square plus 3x minus 2 equals to 0. This is a quadratic equation, and I can write it as 2x square plus 4x minus x minus 2 equals to 0. Right? Take 2x common, x plus 2 minus 1 common, x plus 2 equals to 0. So 2x minus 1 and x plus 2. That means x is equals to half, x equals to minus 2. All right, Gautam, Shabya, Abdul.
Yes, sir.
All right, Gautam, clear?
Yes, sir.
All right, another question. Let f is a function from R to R be given by f of x equals to x square plus 3. All right, find, first part is x such that f of x equals to 28 pre-image of 39 and 2. under f. All right, I'll give you 2 minutes. Here you have to simply solve the equation. Here put the value of x square plus 3 as 39 and 2, find the pre-image. Pre-image means the value from first set, right? I'll give you 2 minutes.
So what is meant by pre-image?
Let's see, pre-image is if two sets are connected in this way, right? A, B, C, 1, 2, 3. Suppose A is related to 1, B is related to 2. Then 1 is the image, A is the pre-image of 1.
Oh,
All
okay,
right.
sir.
Yeah, the input value. All right. All right. All right, we'll check. Gautam, getting this? Gautam, do you have the answer?
Sir, 1 minute, sir.
1 minute, all right. Done, Gautam?
Sir, I got first one.
All right, see. The first one is saying f of x should be equal to 28. All right, so f of x is x square plus 3. So x square plus 3 equals to 28. That means x square equals to 25. That means x equals to plus minus 5. Easy. All right. For the second part, see these two parts are same. Here they just wrote x. Here they wrote pre-image. All right. Rest of the part is same. The second part they are asking f of x equals to 39. So x square plus 3 equals to 39. That means x square equals to 36. X equals to plus minus 6. Right? This is the pre-image. 6 and minus 6. In the third one, f of x equals to 2. That means x square plus 3 equals to 2. That means x square equals to minus 1. And we know this is not possible in real values, real functions, right?
Complex number.
Yeah. So there is no pre-image of minus 1. Right? Clear, Gautam?
Yes, sir.
All right. Next question. F is a function from R to R. Be defined as follows. F of x equals to 1 if x belongs to Q, minus 1 if x does not belong to Q. All right. You have to find f of half, f of pi, f of root 2, range of f, pre-image of 1 and minus 1. Q means rational, right? Rational numbers. See, this type of function is called partition functions. All right. Here we divided the function into two parts according to the domain, right? If x is the domain is a rational number, then we take the function as 1. All right. Here the function was x square plus 3. Here the function is 1, only 1. If it is not a rational number, then we take the function as minus 1. All right. Clear? Gautam?
Yes, sir.
All right. Now try to solve this. All right, done. Gautam, Abdul, Arsalan. Abdul, are you getting this or not? All right. See, here the function is 1 and the function is also -1 given what you put the value of x, right? So when we are putting f of half, that means x equals to half. Gautam, is half a rational number or irrational number?
Sir, rational.
Rational. That means x belongs to q. So when x is belonging to q, that means function is 1. So f of x equals to 1, put half. There is no x, so the value will remain as 1. So f of half is 1. All right, this type of function is called constant function. They remain constant throughout the domain, right? After that, f of pi is a irrational number, so this is -1. F of √2 irrational, so -1. Range, see, a real number can be rational or irrational, right? There is no third option. So either the value will be 1 or -1. So range is -1 or 1. All right, pre-image of 1 and -1. When are we getting 1? When x is a rational number. When are we getting -1? When x is a rational number. All right, clear?
Yes, sir.
All right. Write down real functions. Real functions. Let f is a function from a to p. F is set to be a real function if a and b are subset of R. All right, write it down. Okay, done.
Yes, sir.
All right. So this is very easy, that if the domain and codomain are both subset of real numbers, all right, they can be rational, irrational, or anything like that. All right, what is domain of? This is very important. All right, star mark as much as you want. Right, domain of real functions. If this is not clear, then this chapter is going above your head. All right, the domain of real functions is the set of all those real numbers for which the expression f of x attains real numbers only. Let's write it down, then I'll explain. All right. See, the simple meaning of this is, what are the values of x that we can put in the function so that we only get the real values or real numbers, right? Nothing like infinite or complex numbers, anything like that. All right. That is why it is called a real function. Assume a function as a juicer. All right. A juicer. Something like this. All right. If you put oranges here, you will get orange juices, right? If you put guavas, you will get guava juice. Strawberries, you will get strawberry juice, and so on. Whatever the value you put, that is called domain. What the values you get is called range, right? This is, we all know. Domain is the values which you put where we get only real numbers as the range, right? We don't want to get infinite or complex numbers. Is this clear?
Yes, sir.
Okay, Gautam, Irfan.
Yes, sir.
All right, let me give you an example. Most basic example. If I give you f of x equals to 1 upon x. Gautam, can you tell me, is there any value of x which will give us trouble? And we don't want to put that number in this function. Any number that comes to mind.
Sir, -1.
-1. Why -1? 1 upon -1 is -1. Is it not a real number?
It is, sir.
Then any other number? Okay. Shavya, do you have any number in mind?
Sir, 0.
0. See,
Because we'll get,
Gautam, yeah, because we'll get infinite, right?
yes, sir.
See, Gautam, if you put 0 here, do you know the value of 1 upon 0? Gautam,
Yes, sir.
do you know the value of 1 upon 0?
Sir, really?
Not 1 upon 0 is not 0. This is not defined. We cannot divide any number by 0. All right. So in denominator, we never want to put 0. All right. So this domain will be r minus 0. All the real numbers we can put, but we cannot put 0 here. Clear to everyone?
Yes, sir.
All right. So whenever you see a function in division, something upon something, and they have asked for domain, always put the denominator as 0. All right. And see which values attain 0 and remove them from real number. That will be your domain. Let me give you an example. find the domain of the following. Following functions. F of x equals to 1 upon x minus 1. All right, see here also something upon something. That means we don't want to have 0 in our denominator. So let me put it as 0. X minus 1 equals to 0. That means x equals to 1. I'll be getting 0 when x is 1. So I'll remove 1 from real numbers. All right. I can put any value here except 1. All right, clear? Gautam?
Yes,
Yes.
sir.
All right. Or Abdul, Arslan, Irfan? Easy?
Yes, sir.
All right. Let's try another question. F of x equals to 1 upon 3 minus x. After that, third would be 2x minus 4. Yeah, do this first. I'll give you 2 minutes. Then first, second and third. Gautam.
Yes, sir.
Okay, what is the answer of second question?
Sir, domain is equal to R minus 3.
R minus 3. Okay, third one.
R minus sir, R minus 2.
2. All right. Are these answers correct? Everyone? Irfan, Shabya, Abdul, Arslan.
So second one is correct.
Okay. What is the answer of third one according to you?
Sir, I wasn't able to do that. We cannot equate it to 0 because
Sir,
we'll get
third
real
one.
number itself.
Sir, third one is R.
Third one is R.
Yes.
Oh, let's see. Yeah, so we all know that second one is R minus 3 because X can not be 3 because 3 minus 3 is 0. 1 upon 0 is infinite. In here, Gautam, look closely. This is f of x equals to 2x minus 4. If this becomes 0, then this is 0. We have no issue, right? This is not in the denominator. This is simple 2x minus 4, right? You can put x equals to 1, 2, 3, 4, any number you like, right? Gautam, is this clear?
Yes, sir.
Yeah, so here you can put any value. So domain is R. All right.
So the next one is R minus half.
R minus half. All right. Gautam, you have this answer?
Yes, sir. Same. Only.
Right, because in the denominator we don't want 0. So let's put that as 0. 2x minus 1 equals to 0. So x is half. So x cannot be half. So R minus half. All right.
Yes, sir.
Good. Stein. Fifth one. X minus 1, x minus 2. Okay. We'll give you 1 minute for this, 1 2 minutes.
Done, sir.
All right. Gautam, done?
No, sir.
All right. I'll give you a few more seconds. All right. See, in the denominator, you don't want 0. So they will be 0 when x is either 1 or 2, right?
2.
Yeah.
R minus 1, 2.
Right. See, when two numbers are multiplied, they can be 0 only when either of them is 0. This is the way to solve. X equals to 1, x equals to 2. I know you can just look at this and say, but this is the proper way. All right. Sometimes when you don't see the way, this is the way. So R minus 1 and 2. All right. Gautam, clear?
Yes, sir.
All right. of x equals to 2x minus 3 upon x square minus 3x plus 2. Try to solve this one. I'll give you 2 minutes.
So should we also consider numerator?
See, in the numerator, if it is 0, then the value is, see, 0 upon 0 is, so 0 upon anything is 0.
0.
So we don't have any problem having 0 in the numerator.
Okay, sir. Okay, sir.
All right. Yeah.
Sir, same answer as the previous one.
All right. Let's give another 1-2 minute to everyone. Okay. All right. Gautam Abdul, done?
Yes, sir.
Okay. So here also the denominator cannot be 0. So x square minus 3x plus 2 equals to 0. Right? This is the way to do maths. This cannot be 0. So we put it as 0. And x minus 2 and x minus 1, I guess, is 0. So x is either 2 or 1. So x cannot be 1 or 2. The domain is r minus 1 and 2. Right? Let's try another question. F of x equals to x square plus 3x plus 5 upon minus 5x plus 4. Let's try. 2 minutes for this also.
Done, sir.
All right, let's give 1-2 minutes to other people. All right. All right. Done, everyone? Gautam, Abdul?
Yes, sir.
Here also the denominator should not be 0. This is x squared minus 4x minus x plus 4 equals to 0. So this is x minus 4 and x minus 1. So x cannot be equals to 1 and so to make r minus 1 comma 4. Right, Gautam?
Yes, sir.
All right. Last question of this pattern. After that, we'll do something new. Here, find the domain. Done? Anyone? Shabya, Irfan, Gautam, Abdul Arsalan. Should I solve it?
So I try solving the quadratic equation by using the quadratic formula.
Mhm.
I'm
Right.
getting first one as -3 plus root of -11 by 2. And the other one is -3 minus root of 11 by 2.
Right. So you are getting complex numbers, right? Because we
Yes,
already know under root of minus numbers is complex numbers.
iota.
Iota. So there is no real value of x here, that if you put, this will become what? 0, right?
Yes, sir.
See, when you put x square plus 3x plus 5 equals to 0, and you find out the value of x, will be getting -3 plus minus square is 9 minus 4
Minus
AC.
11.
Yeah, minus 11.2. Right. So this minus 11 is the double here. This is complex number, iota, imaginary number. So what this says is there is no real value of x which will get us 0. So this will never become 0, right? And we are getting problems
Yes.
because the denominator becomes 0, but this will never become 0. So you can put the value of x as anything. So domain is R.
Yes, sir.
Clear? All right.
Yes.
Gautam,
Yes, sir.
all right. See, this is one type of question where you have to check the denominator, all right. Another type is f of x equals to under root x minus 2. We know that under root doesn't like negative numbers, right? It becomes complex. So whenever you see under root and the question is saying asking for the domain, always keep the whole quantity that is in the under root as positive, greater than equals to 0, right? Because under root doesn't want negative numbers. It either wants 0 or positive numbers. So all the quantity inside the root will become positive and greater than equals to 0. So x should be greater than equals to 2. This is our domain, right? How to write this? X belongs to 2 to infinite. Here open brackets, this is close brackets, right? 2 to infinite. Clear?
Yes, sir.
All right, Gautam.
Yes, sir.
All right, this is inequality. We already studied the chapter. Irfan, right? Clear?
Yes, sir, we had studied.
All right. Next question. F of x equals to x minus 4. Third question is f of x equals to 4 minus x. Find the domain of both. All right. Okay, here x should be x minus 4 greater than equals to 0. That means x is greater than equals to 4. So x belongs to 4 to infinite. Here close brackets, here open brackets. Yes. Here 4 minus x should be greater than equals to 0. That means x should be less than equals to 4. That means minus infinite to 4. Here close brackets, here open brackets. All right. Notice this
Yes.
close brackets. Yeah, don't forget this close brackets. All right. They'll take your marks away if you forget about this. Next question. F of x equals to 1 upon under root x minus 1. Try to solve this. Find the domain. Gautam, clear these two questions, second and third?
Yes, sir.
Yes. Try to solve this fourth one.
Sir, over here, should we equate the denominator as 0?
No, see, I told you the denominator cannot be 0, right? So this is the two functions combined. You have to check for the denominator also and the under root also, right? So
Okay,
this
sir.
can only be positive, cannot even be 0, right?
Yes.
All right. We see here we have to do x minus 1 is strictly greater than 0. So x is strictly greater than 1. That means x belongs to 1 to infinite, open brackets both. Shravya, you have put close brackets on 1, right?
Yes, sir.
Yeah, they will take your marks away if you put that, right?
Okay, sir.
Yeah, so x cannot be 1 because it will become 0, right? Gautam, is this clear?
Yes, sir.
All right. New type of question again. So this is clear, right? Okay. It's 1 f of x equals to under root square minus 4. Try to solve this. X square minus 4, right? Okay. What is the steps to follow here? Also, x square minus 4 greater than equals to 0, right? How to solve this? Gautam, how to solve this?
Sir, x square greater than or equal to 4.
Okay.
And x greater than or equal to plus or minus 2.
Is this your answer?
Yes, sir.
No, this is not the answer. Remember the chapter inequalities. We factorize here. The way to go, factorization, x minus 2, x plus 2 is greater than equals to 0. Now wavy curve method. You remember that? We want the positive one. So this is the area. This is the number line, right? So x belongs to minus infinite to minus 2. Close brackets here. Union 2 to infinite. Remember, Gautam, how to solve this?
Yes, sir.
Yes. Shabya, Irfan.
So could you explain this method again?
All right, see. Whenever you are stuck in an inequality and there is higher power of x, the first step is to make the coefficient positive of x square. See, let me show you an example. You can see the lectures, all right, also of inequalities. If you have like this, suppose you have to solve this. The first step is to make this positive. How to do this? Take minus common, multiply negative both sides. When you multiply negative, the inequality sign changes. All right, so this equation becomes this. Now the second step is to factorize this. Factorizing is x minus 2, x plus 2. Now draw a number line. Draw these factors. Here x equals to x minus 2 equals to 0. That means x is 2. Again x plus 2 equals to 0. That means x is minus 2. Plot these factors only. Start from plus, minus, plus alternatively. If there were 3 factors, I would have plot 3 factors, then change the sign alternatively. All right, but here we have 2 factors only. This says we want positive numbers only, right? Greater than equals to 0. That means positive. So take the area which is positive. All right, this is minus infinite, this is infinite. So positive area is minus infinite to minus 2. Close brackets. Union 2 to infinite. All right.
Sir, infinity is open bracket, right?
Sorry, your voice is breaking.
So minus infinity is open bracket, right?
Oh, sorry. Yes, this is open. Right. This is open brackets. Minus 2 is close brackets. All right.
Yes, sir.
Okay. Irfan, clear?
Yes, sir.
Try to solve this then. 4 minus x plus 1 upon under root x square minus 1. You have to find the domain. All right, let's check. In here, 4 minus x should be greater than equals to 0. That means x should be less than equals to 4. So this is minus infinite to 4. Right? Close brackets. The second part says x square minus 1 should be strictly greater than 0. So x minus 1 into x plus 1 strictly 0 means 1 minus 1 1 plus minus plus. So this and this, right?
Yes, sir.
Minus infinite to minus 1. Sorry, open brackets all the sides. 1 to infinite open brackets. Now see, we have two values. One is saying x belongs to minus infinite to 4. Otherwise saying minus infinite to minus 1 union 1 to infinite. This is a single function, right? So we have to take the common of them. How to choose that? Draw the number line again. Minus 1, 1, this is 4. One is saying minus infinite to minus 1 and 1 to infinite. The other one is saying, let me change the color, minus infinite to minus 4, right? So you can take the elements which has both the lines. Which part has both the line? This minus infinite to minus 1 till this, then 1 to 4, right? Yes, why taking open brackets? Open brackets because this is in the denominator, right? This cannot be equal to 0. In
Okay,
here,
sir.
we can take close brackets, but in here, open brackets, all right? In here, minus infinite to minus 1, both the lines are present. This is only single line, so this cannot be included in the domain. In here, only this part, both the lines are present. So the final answer would be minus infinite to minus 1, open brackets, union 1 to 4. Here open bracket, here closed, because 4 had close brackets. Is this clear? Shabya, Irfan, Gautam?
Yes, sir.
Yes,
All right. Absolutely clear, right? How to take intersection of two
yes, sir.
specific. All right. Write down range of a function. The range of a real function. The real function is the set of all real values taken by f of x at the points in its domain.
So what is that word after range of, the range of?
The range of real function. A real
Okay,
function.
sir.
Yeah. You guys are new here. You should know that I have a really bad handwriting. All right. None of my teachers could remove that bad habit. All right, so what is range? Range is the value we get, right? I explained. Suppose this is a juicer mixer, suppose anything like that. Right? Whatever value you put as its domain, the values you get in here is the range, right? As simple as that. So we have to figure out all the values we can get of a function. Write down the question, write the domain and range of the function. F of x equals to x minus 2 upon 3 minus x. All right, find out the domain. I'll explain how to find range. All right. Then what is the domain here, Shafia?
R minus 3.
R minus 3. Okay, before finding the range of this function, I'll explain how to find the range of a simpler function. Start by a simpler function. F of x equals to, suppose 2x. What is the domain here? What is the domain here?
The real numbers.
Real.
All
So
real
R,
numbers.
yes, all the real numbers. So how to find range is write down y equals to 2x, right? Here, find the value of x in the terms of y. So this will be y upon 2, right? Now,
Yes, sir.
whatever value you can put here in y is the range of this function. All right. So we can put any value for y, right? Real number. So the range will be a real number. Is this clear?
Yes, sir.
Yes, sir.
All right, Gautam, Abdul. Yes. All right. Now try to solve this again. Here we had y equals to x minus 2 upon 3 minus x, right? Yes. Multiply them. This can get tricky. So this is 3y minus xy equals to x minus 2. Bring all the x terms together. So this is x plus xy equals to 3y plus 2. Taking x common, 1 plus y equals to 3y plus 2. So x equals to 3y plus 2 upon 1 plus y. Is this step clear?
Yes, sir.
Yes, sir.
All right. We need to find x in terms of y. That's what I did. All right. Now, what is the value I can put in here as y? Or you can say domain of this function.
All real values except minus 1.
Yes, r minus 1.
Yes, sir.
Right. So this is the range of f. Is this step clear?
Yes, sir.
All right, Gautam.
Sir, can I explain once more?
Yes. See, we had y equals to this. I have to find x in the terms of y. Here y is in the terms of x. So I multiplied them. brought all the x together, all the y terms together, and finally I got x equals to 3y plus 2 upon y plus y, 1 plus y, right? This is simple equation we did till class 10th, right? Just interchanging the terms. Now assume that this is another function. If they have, you have to find the domain. How to find its domain? The denominator cannot be 0, right, Gautam?
Yes, sir.
So y cannot be -1. Is this clear? Y cannot be -1.
Yes, sir.
And look at this. This is y. Y is the range, right? So y cannot be -1. So range cannot be -1. So r minus -1 is the range of this function. Now clear?
Yes, sir.
All right. F of x equals to 1 upon 2x. Domain and range, both. 1 upon 2x. Try to find domain and range. All right. Domain is r minus 0. X cannot be 0.
Yes, sir.
Right. How to find range? Same method.
So same thing itself.
Yes. 1 upon 2y. So y cannot be 0. So range is also r minus 0. Gautam, clear?
Yes, sir.
All right. Another question. F of x equals to x square. Find the domain and range.
Sir,
Yes.
in this function, can we write for the range r minus z?
R minus Z.
Sir,
No, you cannot write that R
sir,
minus Z.
range,
Yes, range also. No, you cannot write R minus Z.
Sir, I'm getting both domain and range as R.
You are getting R. All right, let's see. Gautam, you have any answer?
Sir, I have a doubt. Like in the if x square never becomes negative, right?
Right.
So we can just remove the integers from them.
Why integers? X square cannot be negative, so you have to remove all the negative numbers, right?
Okay, sir. Okay, sir. Even the decimals also, right?
Even the decimals, right? All the real
Okay,
numbers
sir.
which are negative, right?
Okay, sir.
Gautam, you have an answer?
No, sir.
No. See, domain is clear as day. This is R. You can put any value here. How to find range? See, here there is two method. One is simple method. See, x square can be never negative, like Irfan said, right? Because the square of any number is always positive. The minimum value it can get is 0. Maximum is infinite. So it can only get from 0 to infinite. Right? This is by observation. But if you want to apply the method I told you, so y equals to x square, that means x is plus minus under root y. Is this clear?
Yes, sir.
So obviously y cannot be negative. We have to put y is greater than equals to 0. So y is from 0 to infinite. That is our range. Right?
Yes, sir.
Yes, sir.
All right. So clear now, Irfan also?
Yes, sir.
All right. So this is all for today's class. Is there any doubts?
No, sir.
No, all right. In the next class, we'll try to finish all we can. All right. Till then, take care.
Thank you, sir.
Thank you,
All
sir.
right.